Okay, you've made it to lesson 60. Good news. You only have 21 lessons to go. And I want you to know that Woody is really proud of you. You're going to need a few things for today's lesson. Lesson 60, finding special products of binomials. You're definitely going to want the reference sheet because the tricks on there, the shortcuts, patterns are on there, and you're going to want to reference that. You're going to need pencil. Going to need a notebook to take notes. Anything you put in here, you're allowed to use on a test. So it's to your advantage to take good notes, pay attention. Remember, you can always hit pause and go back and write down what's on the screen there and get as much of it in your notebook as possible. You're going to want to have printed out that homework paper from the email so that you can scan that or take a picture of it or put it in the mail so I can grade your work and give you credit. You probably also want some hand sanitizer and a bag of pennies, but if you don't have those, I guess, you're just kind of taking it kind of risky like, all right? So today we're going to talk about, this might sound like something tricky, algebraic and whatnot, but I'll show you that actually this is some patterns that will help you do things faster. And I'm going to start with some things with mental math. Now, in our thing here, it says special products, and products means that this is going to involve multiplication. Okay, that's what a product is. It's the answer to a multiplication problem. And binomial will be something like what you can see down here, where we have a term multiplied by another term. Or two terms. That's just what a binomial means. Two terms, like A plus B. And we'll look at the patterns that come about when you square things and when you multiply things by one another. We're going to use some foiling today, but then also I'm going to show you the patterns so maybe you actually save yourself a step or two and get your work done quicker, which I think is sounds good. Well, we're going to take something first here that's just multiplication type of problem. 102 times 98. Now you can do it the long way, and you can go this times this times this times this times this times this. Remember where to put your zeros and to hold things. But a quicker way to do this is to realize that 100 is actually 100 plus 2. 98 is actually 100 minus 2. Now the reason why that matters is that I just set that up like a binomial. It has two pieces, okay? And 100 times 100 is easy to do. And 100 times 2 is easy to do. So if I set 100 to be A for now, and I'm going to set 2 as B, I can follow one of the rules that we'll get to at the end of the lesson and know that A plus B times A minus B has to be A squared minus B squared. So this problem turns into 100 plus 2 times 100 minus 2. Now I could do the FOIL method and I could multiply all that stuff together, but I know that the answer is going to be 100 squared minus 2 squared. 100 squared, 10,000. 2 squared is 4. Don't even need my fingers for that one. And I can get that math done a lot quicker if I just recognize the pattern. Otherwise, there's a lot of work down here and a lot of places that you can make a mistake. But if you recognize the pattern and apply it, we call that a shortcut. Here's another one, smaller numbers, okay? I can think of maybe 3 or 4 different ways to do this. But we have the same kind of setup. Because they're close together, we have 20 plus 3, 20 minus 3, same pattern, A plus B times A minus B. So what we have here is that this has to equal 20 squared minus 3 squared. 20 times 20 is 400. 3 squared is 9. 391. Math goes by really fast that way. And we're going to apply that when we have A's and B's and when we have X's and numbers and things like that. That's what we're going to do today. So pattern equals a shortcut. So have I got your attention yet? Because you want to apply a pattern. A pattern is something it's a generalization that's true in many different situations. So that if you can recognize that something's set up a certain way, you apply the shortcut and you can get to your answer a lot faster. Now, I want to give you two things to watch out for that are common errors that algebra students do. Is that they see something like a plus b squared, and right away they go like this. They go, oh, that's easy. I just square the a and I square the b. But that's absolutely horribly wrong, okay, for many reasons. Is that this is in parentheses, which means this whole thing has to get multiplied by itself. Now, here's the other thing. They see this and they might think, oh, that's a squared minus b squared, but that's not true either. What these things are equal to is a plus b times a plus b and a minus b times a minus b. The FOIL method will give you 4 pieces that you have to combine, and the middle 2 pieces will go together. And what we'll see is that this generates a pattern, a generalization. We would go a squared plus ab plus another one of those. B times a is the same thing as a times b plus b squared. So if I want to simplify this middle piece, I have 2 of those. And there's your pattern. A plus b squared equals a squared and 2 times a times b and b squared. All you have to do is identify what is a and what is b, and then you can apply that pattern. The same thing is true with this. Everything's the same except in the middle it's say minus and minus. So this pattern ends up being a squared minus 2ab. And then when you go negative b times negative b, that makes a positive b squared. So that's the pattern for that one. You can find that on your algebra reference guide. It is on there under common factoring examples. And so you definitely want to keep that handy and put it down into your notes so that you can reference that and use it later on. Okay, let me show you one more pattern with this. Instead of a plus b times a plus b or a minus b times a minus b, what if we multiply one of each? What kind of special pattern does that make? So let's just do the math. We'll get a times a is a squared. A times negative b is negative ab. B times a, we'll get a positive ab. And then the last two here, we get negative b squared. You notice that those two are opposite of each other. They will cancel each other out. So this actually just equals a squared minus b squared. If you can see that setup, you can go straight to your answer by taking the first number squared minus the second number squared. So this is the third magic pattern that you want to look for when you're finding special products of binomials. You notice that this was actually the answer to one of the errors that people typically make of a minus b squared, that it's actually this is what makes a squared minus b squared. Now what about a squared plus b squared? How do you get that by multiplying two binomials together? Well, the answer to that comes later in math because it involves a different kind of number in order to do this. It's called complex numbers. And that is something for something much later. We need a whole different number system in order to get a set of factors that multiply that make this right here. So you're going to have to wait for that. But let's take some examples with real numbers and do this. Now I know that this is x plus 2 times x plus 2. But I already know what a plus b squared happens to be. I got that on my reference sheet right here. A plus b squared is a squared plus 2ab plus b squared. So if I apply the rule right away, I'll get the first thing squared plus 2 times the first thing times the second thing and the second thing squared. Or x squared plus 4x plus 4. That math happens pretty fast if you do it that way. You can do the distributive property here, go x squared plus 2x plus another 2x plus 4, but then you'll have to combine the middle terms, and it makes an extra step for you. I made an extra step for myself because I'm just following the pattern of 2 times a times b to get my my final answer there. Okay. That's with x plus 2. Now, I'll make one that's a little bit more complicated here for my second one, and that would be 2x minus 7 squared. Now, that means that 2x is the first thing, and negative 7, now let's do it that way. Negative 7 is the second thing. Or let's just say 7 is the second thing, and we'll use the pattern a minus b squared. Okay, so a minus b squared was a squared minus 2ab plus b squared. Since I know what I want a and b to be, I can just plug those in. This is 2x squared minus 2 times a times b plus b squared. And simplifying, I got 2 squared and x squared. Here I'll have 2 times 7, so that's 4 times 7 is 28. And I have an x in there, and 7 squared is 49, and we're done. So I applied the pattern, and I can get to my answer pretty quickly that way. Let me do one more that I believe the book has, and that's if you're supposed to multiply these two together. And this is just a plus b times a minus b. X is a and 3 is b. And we knew that that answer gives us a squared minus b squared. This is the same thing as those mental math problems that we did at the beginning. And so we can just jump right to it and say, well, this must be x squared minus 9. X squared minus 3 squared. And then we're done. We don't need to go any further unless they tell us what x is equal to. I'm going to hit pause for myself, and we'll do one more set of kind of some mental math problems, and then we'll be done. You can get working on your problem set. Okay, two quick problems right here. One involves squaring, could be fairly large numbers. Another one is going to involve something when you notice that the numbers are close together and how to multiply them together. Now, I don't know about you, but I do not have 39 squared memorized. I have up to 12, 13 squared memorized, maybe up to 20 squared memorized, but I do not know what 39 squared is. But we can use the fact that they're both close to 40. 39 times 39 is actually taking 40 minus 1 times 40 minus 1. And I look up at my patterns, and that is the same thing as a minus b squared. Okay, so I can apply that one pretty quickly to 40 minus 1 times 40 minus 1. And I know that my answer is going to be a squared, which is 40 squared, which I can do. It's just 4 squared with a couple of zeros on the end of it. Then minus 2 times 40 times 1. Times 1 is not easy, is not hard. And then add on to that a 1 squared. So this is 1600. This is minus 80, and this is plus 1. 1600 minus 80 is 1520, plus 1, and there's my answer. And you can do it in a calculator, but that would be silly. I mean, you're just trying to learn something. And then close together, we notice that this is 20 minus 4 and 20 plus 4, and that would be this pattern right here. So my answer is going to be a squared, which is 20 squared, minus 4 squared, or 400 minus 16, 384. There you go. That's your lesson for today. I hope that you recognize those patterns and then use those shortcuts.